think this one doesn't work for me. Yeah, okay. Okay. Hello, everyone. I'm Jieyu Zhao from UCLA. Today, I'm going to talk about our work, gender bias in contextualized word embedding. So we have known that word embedding has already become a fundamental technique in NLP. It maps words with similar meanings to close positions in the embedding space. So the surrounding words could give us some method to analyze the properties of the target word. For example, we can analyze the different occupations for different genders. And here is the result. We show that a larger font size here means a closer distance to the target word. We found that in the neighbors for he, we have occupations like businessman, mechanic, and engineer. But for she, we have receptionist, babysitter, and nurse. So such bias in word embedding could cause discrimination in downstream tasks, such as a coreference resolution. So next. So coreference resolution is an important task in NLP. The goal is to extract all the phrases referring to the same entity in the text. So for example, the first sentence here, the president and he is referring to the same person. But if we change the pronoun from his to her, the correct link will break. And also the system will fail to correlate females with certain occupations like lawyer, doctor, or programmer. So our work is based on previous observation. So even though there are now a lot of work talking about the bias in word embedding, there's a few talking about the bias in contextualized word embedding. Contextualized word embedding has shown the performance improvement in a lot of NLP tasks. Yeah, so, but we are interested in understanding if there is bias in the contextualized word embedding, or if there is bias, will it influence the downstream task or not? So to be specific, we'll use ELMo as one example in this work. So next, I will talk about the first section of our work. We'll show that ELMo is sensitive to gender. We'll show that the training corpus for ELMo is biased, and ELMo will treat different gender unequally. And also, the bias in ELMo will also propagate to the downstream task. So before doing that, we have a quick background about ELMo. So traditional word embedding will assign a fixed vector to a word, even though the meaning is different. In ELMo, it will make use of a pre-trained language model. And when assigning a vector to a word, it will take the corresponding context into consideration. For example, the two places here will have different representation using ELMo. And the context information in ELMo makes it contains richer information, which will help the downstream tasks. Okay, next I will talk about the bias in ELMo. So we first look at the training corpus. We know that in general, the corpus we collected is actually imbalanced, and the same situation for ELMo. We see that the whole data set is biased towards men, and the male pronouns occurs more frequently than female pronouns in this corpus. Also, as we are interested in gender bias, one way is to look how people are mentioned in the sentence. So we also count the co-occurrence of male and female pronouns with different occupations like doctor or nurse. So again, we see that the data set is biased towards male pronoun. And no matter what the gender inclination or this occupation was. So we see that the training corpus is biased. Next, we want to show that if the ELMo embedding we got from this corpus is also biased. So to do this, we'll first look at the previous one. We'll look at the gender geometry of the ELMo. So to do this, we'll use paired synthesis. So the difference between these paired synthesis is the gender-related words in the sentence is different. And also the sentence the sentence will also contain occupation words. We then extract the ELMo embeddings for those occupation words and get the difference between those occupation ELMo embeddings. And we use it as our gender direction. After we do PCA analysis on this gender direction, we found that the first two components will explain more variance than the others. So to better understand these two components, we project the ELMo embedding of those occupation words to these two components. So the orange dots here means there is a female related word in the sentence. We call it a female context sentence. And the blue one means it's a male context sentence. So we see that the first components, the x-axis here, actually separate different contexts. For the second component, the y-axis, it will group words based on different gender, like male-biased words like developer or driver will lie on top of the figure. Okay, so next we will show that, for now we show that ELMo embeds gender in its embedding, so next we will show that it will treat different gender unequally. So to do this, we will build a classifier to predict the context gender based on the occupation ELMo embedding. So here is one example. We will extract the previous one. We will extract the ELMo embedding for the occupation word in the sentence. And in the sentence, we will treat the occupation as mentioned to a person, and its gender is generated by the gender-related word in the sentence. So the classifier will use the ELMo embedding for this occupation to predict if there is a male word or female word in the sentence. So we found that the result of such classifier is far higher than 50%, also indicating that ELMo can propagate the gender information from the context. But for different genders, we see that the accuracy is 14 more accurately when we're predicting for male context than female one, indicating the unequal treatment of gender. So we see that ELMo embeddings are biased. Next, we want to see if such bias will influence the downstream task. So again, we will use the coreference resolution in English as one example. To analyze the bias in coref, we will make use of the window bias dataset we built last year. So the dataset will contain two subsets. One is called pro-stereotypical, one is called anti-stereotypical dataset. So each sentence will contain two occupation words and one gendered pronoun. The two occupation words will have different inclination to genders. And the correct link in the sentence, so the difference between the pro-stereotypical and anti-stereotypical is that whether the correct link in the sentence will follow the society bias or not. So by saying society bias, I mean we can get such information from the labor statistics. If one system doesn't make any gender-biased decision, it should have similar performance on these two subsets. So we will use the performance difference between these two subsets as a metric to evaluate the bias in coref. So here is the result. So we see that if we use ELMo, okay, go previous one. So the previous one. So we see that using ELMo, we can boost the performance on the benchmark data set, but at the same time, it also enlarges the bias. So by far, we have seen that ELMo has a bias in its embedding, and it also influences the downstream task. Next, we want to discuss our method to mitigate such bias. So in the next section, I will talk about our mitigation method. So before doing that, I will first discuss about the gender swapping technique, which is a foundation of our method. And then I will talk about two methods. One is data augmentation, one is neutralizing ELMo. So let's begin with the gender swapping. So this technique was proposed in our last paper. So the thing we do is that given one sentence, there is one gender-related word in the sentence, and we will keep all the context the same and change the gender-related word to the opposite gender word. So all the correct link in this sentence will keep the same. We can get a gender-swapped variant for this instance. So our mitigating method is based on this technique. The first method we propose is called data augmentation. What we do is we generate a gender-swapped training variance and union it with the original training set. We then retrain the whole model on this union data set. And we show that with this method, with this data augmentation method, we kind of mitigate all the bias shown in the window bias data set. So we see that this method is effective, but we need to retrain the whole model. What if we don't want to retrain? So this is the second method called neutralizing ELMo embedding. So what we do is like for each sentence in the test data set, we will first get its gender swap variant. And then we average the ELMo embedding for these two sentences to get a new representation for the input sentence. And then we do the coreference. So the results show that this lightweight method can keep the performance, but at the same time mitigate some of the bias in the system. So we show that this method is lightweight, but can also mitigate some bias. So and then to conclude this paper, we show that ELMo is sensitive to gender, partly because the training corpus is biased. And the ELMo will treat different gender unequally. And such bias will propagate to the downstream task. And also we have two different methods to mitigate such bias. One is data augmentation, and we see it's very effective when it works with contextualized word embedding. But if we don't have access to the training corpus, neutralizing the test ELMo embedding can also help us to mitigate some bias. Okay, so that's all. Thank you.
Is it on? All right. Emily Bender, University of Washington. First question, what language was this on?
Yeah, it's in English. That we said we use the coreference in English.
All right.
Yeah.
Sorry, I was busy tweeting and missed that.
Yeah.
Thank you. Second question is, I'm wondering how the what you call gender swapping data set can be generalized to handle a view where gender is not considered binary, but actually a continuous variable.
So for the current version, like we need to have, like this method currently is kind of, how to say, it's an easy version now. It's like a simple version now. So we have kind of rule-based swapping now. So if you have like different gender like markers like more than 2 binaries, you can also have such rules to make the swapping thing. But it's like, I think also there's another paper I think talking about how to like automatically, based on a rule-based method, you can get this swapping data set. Yeah.
Thank you.
Questions?
So I'm Vivek, I'm from University of Utah. So my question is like, you say gender swapping sometimes like replacing word with different gender and doing, but doesn't that for some applications like co-reference resolution and all this, gender is important in identifying what is related to what? So where do you think this method should be applied? And
yeah, I think like in our case, because like for the gender bias, we focus on the occupation can be how it's referred by the gender pronoun. So in this case, we don't think the gender pronoun is actually the most important thing to identify this correctly. Yeah. But like for different names, yes, it's true. Like the name is important, can reflect some important thing about the gender. Yeah, so but in the gender swapping method, we also consider this situation. So before doing these swapping things, we will first anonymize the data set, like replace the name with some tokens.